So now in this video, we're going to look at the RC time constant curve of a discharging capacitor right there. So I had this basic setup for the most part. In the last video, we also had an LED in series with the resistor. And when I closed the switch, the LED lit up right away, the capacitor charged instantly, and it took quite a bit of current though. I had to make sure the meter could provide that current, but it was really brief. And then when I released the switch, the LED stayed, really well lit for a brief period of time, but it quickly dropped and faded to off. So if we were looking at the curve, which we're going to do in this video with the oscilloscope, the voltage would be holding as long as I had the switch pressed. As soon as I release, it rapidly drops as the capacitor is discharging through the resistance there and slowly fades down to zero. Now, to calculate how long that is going to take, first you take the resistance times the capacitance. So that's a 1000 ohm resistor, and that's 1/1000th farad capacitor right there. So 1 millifarad, or a 0.001 farad right there. And then times 1000. 1/1000 times 1000 is 1. Pretty straightforward. So that 1 second is 1/5 of the time it's going to take to go from fully charged to fully discharged through the resistor. So right there you can see it's 1/5 of the time, which is going to be most of the voltage drop right there. But then you got some more time where it slowly discharges. After about 5 time constants, there's still a little bit of discharge, but you don't really consider it anymore. It's close enough to zero to just say zero. And so here we are at the breadboard. I still have the LED, we'll remove it shortly, but we have that orange jumper from the positive supply to the top of the switch, bottom of the switch to a 1 kilo ohm resistor that's protecting the LED, in series with it, long lead the anode, short lead the cathode right there, so that it will light up when we press the button. Now you're also going to see the oscilloscope here. I have the cable that comes out of there. There's 2 alligator clips. They're clipped to jumpers that I pegged into the board so that I can easily move them. So I'm going to put that red one next to the resistor, and it's going to look at the voltage in relationship to the negative rail there, ground, right there, the 0 volt reference point. And right now there's nothing because the switch is open. So it sees that connection there only. It doesn't see up there until I hit the button, and then it shoots right up to 5 volts. If I let go of the button, drops right down to 0 volts. So now we'll add the capacitor, 1000 microfarad, and that connects straight across through this switch, and we should see about a volt on there. No, we don't, so I must have discharged this. But now when we hit the button, now you can see we got the 5 volts again, and when I release the button, it slowly curves its way down. Now it's not going to curve to 0 because we have the LED right there. So we got 6 squares over here, but you can see that that's when I release the button. 1, 2, 3, 4, 5 right there. And you can see at 4 it was still slowly curving down, but it was still almost discharged there by 4. But 5, it's still going down a little bit more, but it's slowing way down. We just consider after 5 time constants that's fully discharged, even though a little bit still trickling out of it. So now what we'll do is remove the LED and look at it with just the resistor. So the LED prevented it from discharging to 0 volts right there. That was the main takeaway. I'll unpause this and I get this scrolling again, and now we will hit the button and let it discharge right there. We'll wait till at least 6 seconds. Let's go 7. Try to pause it on that line. I'm a little off, but that should be good enough. But in any case, you can see there 1, 2, 3, 4, and looks like it's still curving down a little bit. And I could raise this up so we could tell a little better. But in any case, the main takeaways, you can see it's about 5 seconds before it is fully discharged. And so that is the RC time constant. Now, the power supply again. Usually I limit it to 20 milliamps or so to protect an LED. I have it up to 0.15 milliamps, and I'll show you why really quickly. I did have it at 0.09, I mean 90 milliamps, but that wasn't quite enough. But when I hit that button, it fully discharged instantly, and we should not have seen ACC on there. I wasn't paying attention, and there you can see we did not. You have to wait till it's a fully discharged. Now what I'm going to do is drop this to 10 milliamps. So I'm limiting how much current this power supply will output. So it takes a burst of current to charge the capacitor, and there is CC on there for a little while. I'm also going to pause this, and you can see that it did not shoot straight up. It looks like it did at first, so there's a capacitor in here. It looks like that covered that much ground, but then it limited the current, and so it slowed down how fast the capacitor charged. It wasn't near as instant as it would be if the power supply had not had the limited current, which we looked at before. So I'm not going to go over that again. But any case, that's it for this video. Hope you enjoyed. Make sure you check out one of the other ones that I'm posting. Click like, subscribe, the bell, and all that. Donate to Patreon if you can. That would help out a ton. I'll see you in the next video.